Frequently in GIS analysis, there's a need to reduce the size of a data set to match the size of a study area. This is especially true for watershed science, where because of the nature and the behavior of the watershed system, things that are inside the watershed are vital to studying its behavior, and things that are outside the watershed are completely irrelevant. So, so we have to often reduce data sets in extent or quantity or in features to the limits of the study area or watershed. The reason we have to do this most often, it's generally a practical one. Most data sets that are available and one can go and download or obtain from some repository have a certain geographic extent, such as the ones that are shown here. One of them is all of the towns and villages in New York State. Another one is the locations of stormwater outfalls around all of New York State. And the third one is a raster or pixel data set, which is a 3-degree by 3-degree geographic area. We usually don't have a choice about what size chunk of material is given to us. We just take a chunk or multiple chunks that cover the study area that we want, and then it's usually up to the analyst, the individual scientist, to trim it and assemble the data set to match a particular study area. So the extent of data sets that are collected and stored and provided never match a study area. The study area is highly specific. So what data sets do I have here? Why don't I turn everything off first and turn them on in order to show. First data set that I'm going to show how it can be reduced and trimmed is a raster data set. It is made up of pixels. It is made up of cells, and we have not looked at this type of data very much, except in the instance of looking at photographs or images, which are always raster data. This is land use, and it is the land use of a particular chunk, 3 degrees by 3 degrees, latitude by longitude, of an area of New York State. That's the appropriate, that's the chunk that includes Northrop Creek, so that's good, but it's much bigger. And you can sort of tell it comes with a default color scheme that's helpful. Blue, water; red is cities; brown is forest; yellow is farms; and green is usually forests. And makes good sense. It does reflect our understanding of the land uses. So you'll be able to see the nature of a raster data set shortly when I zoom in. Another data set is statewide, and that would be the village, or I guess it's cities and towns. Towns and cities are in one data set, and there is actually a reason for cities and towns to be in one data set and villages to be in another. People who live in a village also are part of some town. Residents of the village of Hilton are also residents of the town of Parma. It's different for cities. A person who lives in a city is not part of any town. So a city is the only layer of local government for a city resident. But somebody might live in a township but not in a village. They only have the town. But a village resident is unique in that somebody who lives in a village also has citizenship in the town that encloses it. So there's all the villages, or cities and towns, excuse me, of New York. We also have all of the stormwater outfalls, which are mapped only for urbanized areas, only for officially census-declared urban areas of New York, the major and minor cities, and their surrounding metropolitan areas of New York. So now the question becomes, and I also on this have a little tiny area here, which is actually the Northrop Creek watershed. So first step might be to get our mental scale in order by right-clicking and then asking to zoom to the layer, and we can see there's the extent of the Northrop Creek watershed. And again, now it's kind of vague. We don't really have any reference. One thing that my experience tells me to do right away is to double-click on what's called the patch and make a transparent or hollow polygon. It only shows the boundary. It's called hollow. So that's useful. Now let's see about maybe the simplest of the three. There's three different ways to reduce a data set size, and I'll say these words over and over, but I'll say them all now, all at once. The ways are called extract. There's also clip, and there's also select. And these are three ways in which by which we can subset data. Each of them has their own circumstances of use, and we'll see that as this progresses. Let's look first at a simple data set, and that is the outfalls. So these are all the outfalls, all the locations where a stormwater system that discharges. We all know where stormwater systems take in water. Wherever there's a grate in the road that stormwater goes into, it enters the system. After it gets all collected and eventually it goes somewhere, it eventually dumps into a stream or other water body, and these are the known locations of those. There's actually two different ways in which the outflows that are inside the watershed can be separated from all of the rest of them. One way to do it is by clipping. So we can do a clip operation, and I'll show you the clip. Anytime you would have to do it, personally, I would have a step-by-step written out, but seeing it makes that part much easier. So what I can do is I can ask for geoprocessing and search for tools. The tools collection in ArcMap is way over 1,000 different tools, so poking through them looking for it is impossible. So it helps to know the name of it, so you can use a clip, and we'll use a clip tool with its designation of a hammer to indicate that it's a tool. And I'm not sure if it should open up momentarily. The first time we ask for the clip tool, I'll risk doubling that up. First time you ask for a clip tool and use it, it runs a little more slowly than later. So here's the clip operation. I'll shrink this window to show you that there's not really much there. So what I can do is I have to specify three different things. One of them is I have to tell it what is the large data set, the dough, so to speak, that I want to clip these points out of. So I can go ahead and say that and there's a drop down here, so I can go ahead and say I'd like to pick from the outfalls. And what do I want to use as the clipper? The cutter is the watershed itself. And I find that it's actually convenient not to try to specify my output feature class right now, but to rather let it go to a default place, let it load into the file, and then save from there. There's different ways to do it. Some of them seem to work smoother than others. So I'm just going to go ahead and say OK, and it will take about a half a minute probably, because it is sorting through a lot of geography and a lot of computation. But shortly we should see the reduced data set. And I got my green check mark. That's very nice to see. Right now I got points on top of points, so what I can do is I can either turn off or remove the source data set. I'm going to go ahead and remove it, and now we see there's a new layer here that has only the outfalls inside of Northrop Creek. There's another step in here, and I realize that early in your careers as GIS analysts, seems like there's a new thing to learn every 2 minutes. Eventually you get your toolbox filled up, and things work more smooth, or are more easy, and you just proceed with doing stuff instead of learning new tools. Right now this data set is in some unknown, semi-known location. What I'm going to do is I'm going to right click on this, and that'll give me a data and export data option. And what I'm going to do is, it's exporting, but it's just resaving, and I'm just going to resave that data, all features as a shapefile, and I'm going to store it in a place of my own personal choosing this time. Inside of an Arc Toolbox tool, it's harder to select your location. Here it's much easier to select the location. So I'm going to go right ahead and find my stuff folder, which I've been using for these videos and for this fall's class, and I would like to give it a new name. I will call it Stormwater Outfalls. This is called camel case, because the letters are kind of like each new word has a hump in it, hump like a camel does, and therefore it's a little easier to read. And I go ahead and say save and OK. And now I can say yes if I want to. And now I have another copy, and I can remove this one. So now I've extracted, I've created a new data set, which I will offline load onto Google Drive for your use, which is all of the stormwater outfalls inside of this study watershed. So that's one down. I'll turn that off for the moment. Another type of reducing of a data set is I just did clip. I'd like to show you another way that I could have. No, I know what I'll do. Sorry, I fumbled here, but I don't feel like restarting this one. I'm so far in. I have here a data set which shows the towns and cities, but there actually isn't one. The only one is over here. But it shows the towns that intersect our watershed. And just for reference, and maybe even to learn you something, I can ask for properties with a right click, and labels, and name, and label, and make it a 12 and bold, and say OK. And now I have a label for each of the towns, and I knew it was Ogden. This piece here is Parma, and this piece is Greece. So this much of our watershed is in Greece, this much is in Parma, and this much is in Ogden. And those are, in New York being a home rule state, those are entirely separate local governments. And anything to do with the watershed is going to have to probably have the cooperation and coordination of all three of these towns. Well, in order to sort of divvy this thing up, I can also do an operation called selecting, and there's something called selecting, which provides a way to reduce a data set. So why don't I go ahead and do selecting. And what I'm going to do is I'm going to select this feature, and this feature, the three towns. An individual element in a spatial data set is called a feature. I'm going to select each of these. There's lots of ways to do that. And then I'm going to export as another data set. And that won't work quite right. Then I'll show you a better way to do it. So I'm going to ask for selection, and I can say selection, and I can select by location. There's lots of different ways to select. We'll select by location for this time. And it says here I want to select features from the data set called cities and towns, and I want to do the ones that that intersect that have a source layer of the or the operating layer of the watershed, and I want to say all of the cities and towns that intersect the source layer, which is the watershed. And I can go ahead and say OK, and now you can see by the blue lines that there are 3 towns highlighted, and well, that's just swell. So now I can go ahead and open the attribute table. That's another little thing I'm sneaking at you. And it says that there's 3 of the 994 towns and cities in New York are selected, and they are Greece, Ogden, and Parma. So far so good. I could go ahead and do my export data, export data, and take those 3 towns and toss them in their own file, but I would still be left with portions of the towns that are outside of the watershed. So not interested in that. So I'm going to say select and clear selected, and we're going to go back and do the clip again in this case. And in this case, the clip will work differently and be a little more complex. When we clipped the stormwater outfalls, clipping and selecting those inside the watershed were exactly the same thing. In this case, the clip is going to look a little different, so let's go ahead and do that. Clip. I will double click. There we go. So now we have input features are the cities and towns. We're going to clip with Northrop Creek, and again I'm going to let it go where it wants to go and say OK. And this is a more complicated feature, so it took 3 seconds instead of 2. So now what I have here, and I'll turn off this, I'll remove the original layer of cities and towns. I now have a data set that has only those chunks of the cities and towns that are inside the watershed. So that's pretty cool. I think that was useful. And if I open the attribute table, I can see that I even have areas of these, calculated areas. And we'll talk about that operation a little later on. But right now I could say that such and such acres of Parma are inside the watershed, such and such acres of Greece are in the watershed, and a certain amount of Ogden is in the watershed. I could say 38% of the watershed is Parma. I have the ability to do some substantial analysis. So that's the use of a clip or a select to do that. And then the last operation I'd like to show, is a different one in which we extract the land uses, and only the land uses that are inside of our watershed. The clip and the select only work for vector data sets, points, lines, and polygons. So that's kind of one world of analysis. In the case of a raster data set, and I'm going to zoom in just to show you a little more, even more so. We'll go up to Braddock's Bay here. To zoom in, this is what a raster data set looks like. It is made up of cells or pixels, in this case cells or pixels that are 30 meters, and I missed the start point on that a little bit. Pixels or rasters that are 30 meters by 30 meters, which is useful. This is a data set in which the values at any particular location are cells. They're not boundaries of polygons, rather each little chunk of equal size has its own value. But that's another lesson. The goal for today is, that's the back arrow that goes back to the previous extent. The lesson for today is to figure out how to chop out all of the land use information that's not part of our watershed, so we can focus on the part that is. And even though we call Spencerport an urban area, I just noticed, compared with the city of Rochester, it is not particularly urbanized, the village of Spencerport. So the keyword in our search here for raster data is extract, and it's called extract by mask. And there's different ways to do extracts, but the one that's going to work for us the best is extract by mask. So in order to, and Spatial Analyst works with raster data, in order to chop this guy down, we are going to extract by mask. And we need to, as is common, and as you maybe are starting to get the hang of it, the understanding of it, we need the stuff that we're going to chop out from. We need a cookie cutter, and we will let it go wherever it pleases. That would be for the moment, and then save it. So why don't I go ahead and say OK. And this is a substantial operation. It's still fast. Must be things are working smoothly today. So now I have an extract, and to see the difference between the extract and this, I just say remove this one, and there are the land uses inside of the watershed. And I can actually open the attribute table and discover that the largest land use, hay and pasture, it comprises 16,000 cells. The second biggest land use is deciduous forest, 14,000, and the third biggest is cultivated crops. And we can do all kinds of analysis using this. But those are the steps, or the methods by which we can reduce data sets. You can select based on any number of rules and then export it. You can clip directly, or you can extract by mask. So clip and extract by mask are clearly cookie cutter operations. Select is a way to reduce the data set which resembles cookie cuttering but has a little bit of differences. But that's the whole story with reducing the data set, and that should help with a number of the operations, individual projects you'll be doing, as well as 2 or 3 of the labs at least.